our next example, we would like to design a recursive method, but this time the method retains a value. For all of our previous examples, the methods were void methods. They did not retain any value. For example, countdown method. And here we would like to design a recursive method that is called sum, that has an integer input parameter n, and the method retains the sum 1 plus 2 up to n. As an example, when we call the method with input parameter n is equal to 4, then the method should return 10 as the result of the sum 4 plus 3 plus 2 plus 1. So to think about a design for the recursive method, we need to split the task of finding the sum for n numbers into a subtask that finds the sum for smaller numbers. To do that, we need to symbolize the call of the method. Similar to what we have done before, if we want to call the method with n is equal to 4, this is how we symbolize the call. We say that sum of 4 is equal to 1 plus 2 plus 3 plus 4. Now we need to find a subtask that finds the sum for smaller numbers. If sum 4 is equal to 1 plus 2 plus 3 plus 4, then we can consider that 1 plus 2 plus 3 is in fact the retained value when we call the method with input parameter 3. So for sum 4, it does not add all numbers. It adds 4 plus the retained value when we call the method with input 3. Now when we call the method 3, it's supposed to add 1 plus 2 plus 3. But in fact, 1 plus 2 can be computed as a retained value from calling the method with input parameter 2. So the retained value from sum 2 will be the addition of 1 plus 2, and sum 3 will use this retained value and add it to 3. Now for sum 2, it's supposed to add 1 plus 2. Also, we can consider that 1 is the retained value when we call the method with input 1. And finally, when we call the method with input 1, we don't have many numbers to add. We have only one number to return from this method, which is equal to 1. And this is why we consider the last call when the input is equal to 1 is the base case or the stopping case. So here we can conclude that for any method, if you want to return the sum of the numbers from 1 up to num as the input parameter, you simply call the method but with a smaller input parameter, which is n minus 1, and then you add with n. So if the input is 4, you add the retained value from sum 3 plus 4. And for sum 3, you add the retained value from sum 2 plus 3, and so on. So to generalize the recursive method, we can say that for any input n, sum of n is equal to sum of n minus 1 plus n. To design this algorithm into Java, this is the recursive method body. First, we make a branching, as we stated before. For the design of any recursive method, you need to split, then followed by finding the base case, and followed by writing the recursive call inside the method body with the branching. So we start with the base case. We say if n as an input parameter is equal to 1, simply returns 1. Otherwise, you call the method recursively by saying return sum n minus 1 plus n. So the retained value from sum n minus 1 will be added to n, and this will be retained as a retained value for the method.